Good morning, welcome to another YouTube tutorial by Prof. Idani. So today I'm going to demonstrate how we find the intersection between two planes. So two planes intersect at a line. Let me quickly demonstrate with a book what we're talking about. Say this is a plane and this is another plane. So where they intersect, it's this line. So these two planes intersect in line, so we need to find the intersection of that line, and we know that to find the equation of a line, we need two things. Like I usually say, there are two things involved. We need a point that passes through the line, and we also need a direction vector parallel to the line. Sometimes when they ask you this question, they might simply ask you to explain without necessarily finding these 2 points. By simply explanation, you get full marks. So to find R0, we assume that two planes cuts the xy plane, and we know that in an xy plane, z is equal to 0. Let me just get another marker. So in both equations, we are going to replace z with 0. We're going to let z to be equal to 0. So this is 2x minus y plus 0. Here we were fortunate enough because it was 0z, which is the same as 0 already. But let me just put that 0 there just to show in case you get a different thing. So if you get an equation in this form, you must know that you have to replace that z with 0, so that we are left with two variables that we can solve simultaneously, because we cannot solve three equations. We cannot solve three unknowns with two equations. 2x minus y equals to 6, x minus y equals to 4. So now you're going to solve these two equations simultaneously. Don't worry, I'm also going to do another video wherein I demonstrate how we solve simultaneous equations, because I'm going to do a video of things that you have already forgotten but you are afraid to ask. So we can call this equation number 1. Let's just call this 1. Call that equation 2. We can just simply say 2 minus 1, or let me say 1 minus 2. Equation 1 minus equation 2. So it's 2x minus x, which is x, negative y minus y, which is y. So our x is equals to 2. From the now from the second equation, from 2, I'm using elimination method here. X minus y equals to 4. This means that x minus 4 equals to y. So y equals to 2 minus 4. This tells us that y equals to negative 2. So this means that our R0 is equals to x, which is 2, y negative 2, and our z, remember initially we said let z to be equal to 0. So now we are tasked with finding v. Now to find v is the vector which is perpendicular to both planes. Like that line is perpendicular to those planes. So in order to find that particular vector, we use the cross product of n1 and n2. You should know how to find a cross product. I'm also going to upload a video that demonstrates how we find the cross products of two vectors, in case you don't know how to find the cross product. So let's continue. So we're going to find the cross product of, now let's identify, since we have to find v equals to n1 times n2, let's identify n1 and n2. So n1 is simply the normal for the first plane, and n2 is the normal for the second plane. So this is 2, negative 1, 0. To find the normal, you simply take the coefficients of, let me just put this here. So this is 2, negative 1, and 0. And then to find the normal of this one, the coefficient of x is 1, coefficient of y -1, coefficient of z 3. Let me put it like this. So yeah, now we can find the cross product v. So I will assume that you know how to find a cross product between two vectors. If you don't know, I'm going to do another video to demonstrating how we find the cross product between two vectors. So we have found our v. Now after finding v using cross product, r equals to r0 plus lambda v. Remember our r0 was the point, now our r0 was the point 2, -2 and 0, and then our v, we've just found it, this is -3, -6, -2. Thank you for watching my video. Please do not forget to subscribe, comment if you've got any questions. Love you all. Have a good day.